Okay, so as of now, we have actually learned two different ways to solve simultaneous equations. Okay, to solve simultaneous equations, we learn table of values and we learn graphical method. Okay, these are the two things we have learned. Quite basic. Table of values is something you've learned in Sec 1. Graphical method is also a mix of what you've learned in Sec 1, and you can apply that to solve for two lines. Okay, the idea here is to always solve for two linear equations. So for example, I have a mini graph here. Okay, I have two different lines, one here, one here. I want to solve for the intersection, which is the solution for the two linear graphs. Now today I will introduce to you the algebraic method. Okay, some of you hate it, but I'm sorry. As long as you take math in secondary school, you have to learn this. Okay? So the first method, some of you may already know, is called the elimination method. Okay? Elimination method. Now, I think I will only focus on elimination today because some of you may already know, but you might keep making errors. So for this part, there might be a need to also practice on your own. Now, when we solve one variable linear, okay, what does one variable linear equations mean? Does anybody want to try? In one variable, what does this actually mean? What does this statement mean? Linear equations in one variables. Ashka, what do you think this would mean? Give me an example. There's only what? One difference. What kind of difference? Maybe what? Sorry? Oh, okay. So you're saying that y doesn't have a number but x have. So something like that. Is it? Are you saying something like that? Okay. Now let me point back to this word. What does one variable mean? This one got how many variables? Two. Right? Because y is dependent on x as well. X is dependent on y. So in this case, there are two variables. Okay. So sorry, Ashika, but this is wrong. Okay. So when we are talking about one variable, actually these are things that you have already seen. One variable linear equations are in this form. There's only x. And usually you will solve for them, right? So you can actually solve for them quite easily. Okay, I will not, from now onwards, right, all these kind of algebraic methods, right, I will skip them a little bit. If you need help, you can just raise your hand, I will help you. Yes? Go and ask Sham. Asham, why 2x equals 14? So finally, x equals to 7. Okay, so these are things are what we covered in Sec 1 already. Like, hey, why is it 2x equals to 14? The idea that we've learned in secondary 1 was to solve linear equations in one variable. To solve for a single x, there's no y, right? But of course, we also seen a different kind of one variable linear equations, which are 2x plus 5, we solve for negative 3x equals to negative 3, x equals to 1. Okay, these are things you've learned last year. Nothing wonderful, nothing new. Okay, now my question here is, can I actually solve a linear equation with two variables? 2x plus y equals to 8. Can I solve this? Can you all try now? There's space for you. Try to solve this. Okay, solve for y and x. Try on your own without using any graphical method, anything. With what you already know, try to solve for them. Okay, if you think cannot be solved, write down why cannot be solved. Where are you stuck at? Okay, 2x plus y equals to 8. Okay, so can we just solve this? Okay, let's see. I want to get Carice. Can we solve this? Why? Okay, Carice say cannot. Why? What do you get trying to solve? Okay, what do you get? What's your next step from here? Okay, 2x equals to 8 minus y. Next. Then start. Start, right? Okay? I'll help you expand a bit. You will try this. But the problem here is, yes, is this a solution for this? No. Actually, it is. But you don't know the exact solution because of this variable y. Now, this is where elimination comes in. You cannot actually solve for x and y if you don't have any other things. You only have one equation here. But when, let's say, I have two equations with two variables, you can actually solve for it. So one equation with one variable, you can solve for a solution. But two equations is needed when there are two variables. Okay? So you all can actually write it down. Okay, to solve a linear equation is on the page 10. Okay, describe what pattern you see between the solutions and the number of variables of the linear equations and the number of linear equations. Okay, you don't really have to describe, but I'm actually going to show it here. Okay, to solve a linear equation with two variables, you will need two linear equations. Okay, this is my short form for equations. Because as we can see, one variable you just need one equation. But when it comes to two variables, you definitely need two. Okay? Then my challenge to you all, okay, which I'll upload on SRS, is to solve. If we have one variable need one equation, two variables need two equations, this would mean that three variables need three equations. Okay? It will be a challenge on SRS for this chapter to solve a linear equation with three variables. That means I will give you, instead of x plus y, there will be z. Okay, but this one is just a challenge. It's not in your syllabus. It's an optional thing. If you want to extend your knowledge a bit on simultaneous equations, this is something you can try out. Okay, but we are not going to go there. Okay, we're only going to stop at two variables. Okay, I'm just showing you how does this look like. Okay, now it's quite scary, but actually it's very simple. It's almost the same method as that. But don't worry, we'll just look at this. Okay, so as I said, we will look at the elimination and substitution method. So I'm going to erase this part. Now the first question here is work example 3. You have actually all the solutions in your textbook. Okay, but I want to just show again because sometimes you may not. You read, you might fall asleep. Okay, so in this case, we have 3x minus plus 7y is equals to 17, and 3x plus minus 6y is equals to 4. Now, elimination method is all about eliminating a single variable. Okay, I say again, elimination method is all about reducing this to only one variable by eliminating the one that you don't want. Okay, so what I'm going to do is I'm going to denote the first equation as 1. Okay, this denotation is very important such that you will understand what your working is doing. I'll name this equation as equation 1 and denote this as equation 2. You don't need to say let this blah blah blah. You can just do this, it's fine. Okay, now I'm going to take equation 1 minus equation 2. Okay, wait, what does this actually mean? I'm going to take everything on the left hand side of equation 1 and I subtract everything on the left hand side of equation 2, and that will be equal to everything on the right hand side of equation 1 subtract equation 2. Okay, how does it look like? It looks like this. 3x plus 7y minus the entire side of equation 2, right? Bracket 3x minus 6y. Okay, then it's equals to 17 minus 4. This is what it means to be elimination. So if you think about it, what will I have left? I only have y variable left. X is eliminated from the whole entire thing. Of course, we will come back and find x later. Okay, don't worry. Okay, but the idea here is to eliminate one of the variables first such that you can actually use that to your advantage. So this is why last year I keep emphasizing on your negatives and so on and so forth. This is where it comes into play. It will be minus 3x plus 6y equals to 13. Y plus, there's a bracket here, minus a subtraction becomes a positive sign when you expand the bracket. Okay? Now you ask me, Joe, how come can just like minus? Don't we need to balance the equation? Right? When I always say you need to balance the equation, right? Every time I say you want to subtract everything from the left hand side, you must subtract the same thing from the right hand side, right? But how come this I can subtract different stuff? Like for example, this one I can subtract this, then this one I can subtract another thing. Why cannot? Why I never subtract 3x minus 6y on the right hand side also? Why?
Because technically we are not even subtracting, we are just simplifying the left equation.
No, wrong.
Because 3x minus 6y equals to 4.
Correct. Because 3x minus 6y is equals to 4. Because of this, we are actually still doing it. But instead of writing 3x minus 6y, it's actually equals to 4. I can just replace it. And I'm playing around with the variables. Okay? So it's not something new. It's actually about balancing, basing on what is given to you all. Okay? So just to take note, if you want to ask me that question, I'll put it on the record. Okay? This is the reason why. Okay, so now back to this. 3x minus 3x is 0. Don't care already. You have 7y plus 6y. That will be 13y equals to 13. How to get this? Y equals to 1. You have one half of the solution already. The next step is you need to find x. So you just need to sub this value of y into any of these. Any, but you need to write this. Sub y equals to 1 equals into equation 1 or 2 doesn't matter. Let's try equation 2. Okay, so what we have here is 3x minus 6 times 1, because 6 times y is 6 times 1 equals to 4. Okay, sorry, I'm going a bit faster. Okay, 6 times 1 is just 6, so it's 3x minus 6 equals to 4. We have 3x is equals to 10. And 10 looks like 6. And finally, x equals to 10 over 3.